Hi everyone, so today we're going to be solving equations when we have like terms on one side of the equal sign. So when solving multi-step equations, you're going to combine like terms before you solve, but you only do that if the like terms are on the same side of the equal sign. So we're going to take a look at an example. So here we have x plus 8x equals 72. So to solve this, the first thing I like to do, draw the train tracks, and we're going to try to identify like terms. So remember, like terms are terms that have the same variable with the same exponent. So we can see here that this x and this 8x are like terms. I'm also going to put this 1 in front because we know whenever there's no coefficient, it has an invisible coefficient of 1. And we're going to combine these because they are on the same side of the equal sign. So if there was an x here and an 8x over here on this side, we would not be able to combine them. They have to be on the same side of the equal sign. So we're going to take this and we're going to add them together and we get 9x. I'm going to bring down anything we didn't use. 9x equals 72. So all we did was add those coefficients in front. Now the last step here, get x by itself, divide by 9. So that cancels. X equals 72 divided by 9 gives us 8. So this is our answer, x equals 8. We have to combine our like terms as long as they're on the same side and then solve it using inverse operations. Now I also want to show you something that's a super common mistake that people make. So here we have 1x. I'm going to just rewrite the equation. I'm going to show you what not to do now. So say, they drew their train tracks. Now, one thing people like to do is they do this. They subtract 1x and 1x. But the reason why we do not do that is because there's no equal sign here. So we can't subtract the 1x because we're not subtracting it over anything. So do not do this. If they're on the same side, just combine them like what we did here. Same side, combine. Okay, let's take a look at another example. Okay, so we have negative 11 equals 11y plus 13 minus 3y. So we're going to start by drawing our train tracks. And we're going to identify our like terms. So here on this side, all we have is a negative 11, so we don't have any like terms. Now on this side, we have this 11y plus 13 minus 3y. We're going to identify our like terms, which in this case is 11y and negative 3y. Remember, if you circle your like terms, make sure to include that sign in front. Now we're going to combine these. 11 minus 3 gives us 8y. And I'm going to bring down anything we didn't use. So I'm going to bring down that plus 13, bring down this equal sign, and bring down this minus 11. So all we did was combine our like terms because they were on the same side of the equal sign. Now we're going to just solve using inverse operations. We're going to move our constant first. So subtract 13 on both sides. That cancels. Negative 11 minus 13, same signs to add and keep. So we're going to get a negative 24. I'm going to bring down this equal sign, bring down this 8y. Divide by 8 on both sides, and you get negative 3 equals 8. Okay, we're going to look at one more example. Okay, so we have 2x plus 6x minus 3 minus 4x equals 9. So there's a lot going on here. We're going to just start off by drawing our train tracks, and we're going to identify our like terms just like what we did before. So we have 2x, 6x, and a negative 4x. Treat that like a negative 4. Now we're going to combine all three of these. 2 plus 6 gives me 8, so I'm going to just make a mental note right there, 8. And then 8 minus 4 gives us 4. So this, when we add all those together, we get 4x. Now I'm going to bring down anything we didn't use. So that minus 3 and that equals 9 comes down. And now we're going to solve using inverse operations. Add the 3 to both sides. That cancels here. I get 4x equals 9 plus 3 gives us 12. Last step here, divide by 4, and you get x equals 3. Okay, so to solve equations where we have like terms on the same side, make sure you combine them before you continue to solve.